Okay. Okay, so thank you everyone coming to this session. So I'm going to talking about the troubleshooting RabbitMQ, share our experience and some stability improvement. I work in Cisco Cisco Cloud Service Department. So this presentation contributed by me and my colleague Kevin Bringard and Wei Guo Sun. So currently we deploy Icehouse and Havana against the RabbitMQ. So one of the issues we found is when we try to troubleshoot, we saw like thousands of the queues listed there, but it's not easy to identify which component consume which queues and what's the message flow. So give one example. You see the first one, that is the queue name. It's a UUID. So what does that mean? From the queue name, you cannot get any information. So actually, this is the queue used by heat. And this is not auto-delete queue. This actually is a regular one. The next one, queue plugin, is start with queue, so probably this consumed by Neutron. But by the Neutron controller or by the OVS agent, about other agent, we don't know. So that's why we think maybe we can spend some time analyze and categorize the queues and exchange. And for OpenStack, they use topic to represent the exchange. So we count the number of consumers. Then, like when the ops troubleshoot, it's like fasten the process. They can understand what happened and how the message flow going back and forth. This is can be done easily by running the script, calling the RabbitMQ management HTTP API. So it's they provide a very good API there. And then we just map the result by the queues, consumers, and the bindings. We bind the result, we get the information. So for example, this is all the queues and consumers, all the queues claimed by Nova, both by Nova controller and the compute nodes. This is for Icehouse. So you can see, for example, the conductor that is consumed by all the Nova controller node. And the exchange name is Nova. So this may be changed for different versions of OpenStack, but just to give you guys an idea how to analyze that. And the Neutron, this is a naughty guy in OpenStack for when troubleshooting RabbitMQ. So for example, queue plugin, we know, okay, so this is consumed by Nova controller node, and they bind it with exchange Neutron. So this is one way to identify the message flow. And this is the telemeter, and you see the notifications.error. This queue is not consumed, it's a bug. It's fixed in kilo. So there's some issue in there already. Okay, so the next big issue when we're talking about the RabbitMQ is in production or in dev environment, we see sometimes disconnection or reconnection failed. So this is may trigger once we shut down one RabbitMQ for failover, or once the OpenStack service like Nova got failover, got shut down. So it's really a pain, to restart OpenStack service just in order to restore the service, because that means like that's impact the tenants. I think like most of you guys already know the tuning for TCP, like the most common one, we try to the TCP Keep Alive, these 3 parameters, right? And these values, 10, 6, 10, this is just a suggestion. So we also, doing some research with partnership companies, we found that different companies have a different setting. But the goal here is we try to shorten the keep alive interval and increase the number of probes so that each end can detect the connection fails as earlier as possible. But the problem of TCP Keep Alive is sometimes this setting is there, but it will never be triggered. Because TCP Keep Alive is not described in TCP specification. So this one TCP Keep Alive is used when the network connection is idle. And then, for example, here, after 10 seconds, and then it start probing with the interval you set here. But if the connection is not idle, for example, is waiting for the acknowledgement, but it never get the the packet, then this TCP Keep Alive setting will never be triggered. So in that case, you probably will still see the connection issue. So how to tune that? And we did some research, and also we got some suggestion from a partnership company. So like one parameter we try to tune is TCP Retry 2. So this parameter is to define how many times TCP want to retry before it can say, okay, this connection is closed. So by default, like in our environment, we use the Red Hat Rail 7. The number by default is 15. That is almost like more than 900 seconds. So that 930 seconds, something like that. So 15 minutes more than. So that means, like, for example, in the previous case I mentioned, if we have multiple Nova nodes, if you shut down one Nova controller node, you don't touch the RabbitMQ, but the RabbitMQ will not know this connection is closed until about 15 minutes. So then we just decrease this number TCP retries to like to some number like you need to test. Like RFC, IETF RFC recommend this retransmission timeout should be no less than 100 seconds. So that is about 8 times of retransmission. So you can set this TCP retries 2 to 8, but in reality, you may even lower that number. It totally depends on your test result. So some people also suggest, okay, so we should use a TCP user timeout. So this parameter is also to identify how much time needed to wait before close a transmission, before close a connection. So the thing is, like, for this tuning this parameter, it requires some kernel update because in old kernel it has some bugs there. Also, if you check the RFC document, it mentioned TCP user timeout is only functional properly locally. It's not well supported for the other end to notify this setting. So that means locally you set this TCP user timeout, okay, it knows it, but the other end may still like waiting for a longer time before it knows the connection close. So that's the reason we think maybe we combine these two parameters together, tuning them, and that can give us a better result. Okay, so but what if, like, in production, like you get a call, say, okay, we see the issue, like OpenStack cannot talk to the RabbitMQ, and you identify, okay, so the connection is there, but actually it's a fake one. The both ends, they cannot detect the connection fails, but you don't want to restart OpenStack. So in order to minimize this impact, what we do is we just close the connection, from RabbitMQ. So in RabbitMQ management HTTP API, it has the REST API that allow you to delete this path. Also, you can just run the RabbitMQ admin command to close the particular connection. So once you close that connection, it will trigger the both end realize, okay, the connection is gone. And in most cases, then OpenStack is able to redeclare that queue in OpenStack, and then you can restart the service without restart any of those. So this minimizes the impact. This is can be easily done in running a simple script, right? So, okay. So the next one, I want to talk about the upgrade RabbitMQ. So in normalized way, we should have the backup RabbitMQ cluster so that you can join the message from existing one and move to the new one. Okay, so then most cases we don't have the luxury for support the backup gear. To simplify that, we just use this method we found in experiment. So we first export the configuration in RabbitMQ, and then we stopped all RabbitMQ nodes. And next step is like in the last RabbitMQ we stopped, we just run the upgrade script. This upgrading script including remove the old RabbitMQ, and if you want to also upgrade Erlang, also remove the Erlang. And then we delete the Manicia database, and also you can delete the crash dump file. Then you install the Erlang and then RabbitMQ service. And then you do the same upgrade script for the next RabbitMQ nodes in the same cluster. So in this method, by using this method, we can control the upgrading time in a few minutes. So if like in that time there's no communication needed, then the tenants may not notice the service interruption. So that's the way we upgrade Rabbit. So I also want to talk about something else. When notified, like in troubleshooting, we found something like we need to. There's often a queue in the RabbitMQ because the OpenStack bugs. So instead of talking about the fix, I'm talking about how you can just set up the per queue TTL to remove those queues. The next one is we found a few times like accident, like people just run the hostname command trying to check the hostname, but if you by accident that command allow you to change the hostname, and then that will cause the RabbitMQ cannot talk to each other because the hostname changed. So that's like we need to avoid. Don't use that command. So then also in existing version, we use RabbitMQ 3.3.5. So sometimes the RabbitMQ CTL command is stuck because it pull out the data at the same time and then give the output. So yesterday, we just heard from RabbitMQ engineer in their new version, this RabbitMQ CTL command is streaming now. So that is like a good function. We can reuse that. But before that version, we prefer use RabbitMQ admin command because that one is just calling the web API, which is supported by multi-web. It's a lightweight HTTP server. Okay, so then like sometimes if you the RabbitMQ really crashed, you want to analyze the crash dump file. There's one script we use and it's very good. That's from Riken. So I put the link here. Or you can just download the crash dump file locally and open the Erlang node and then run the crash dump viewer tools to view it. This gives you more detailed information, which process has a problem, and what's the item and those how and memory consumed. So you can get more information from that. Okay, so the last one I talk about like run the Erlang command for troubleshooting. So you know RabbitMQ CTL, RabbitMQ is built in Erlang. So you can just run the RabbitMQ CTL, evaluate, and then give the Erlang expression there to actually run the Erlang command towards the Rabbit. But sometimes I prefer, personally I prefer I just you just use the same cookie as what Rabbit use, and then you create another Erlang node. Then you just run the Control G. You can start a Erlang job control mode. It's called JCL. Then you can just console into that RabbitMQ server, and from there you can run whatever command you want to use. But probably in the dev environment, don't try that in production. Okay, so I think the time is over. So that's my short presentation today. And if you have any question, we can talk about outside or send us email. Thank you.